podcast, I didn't feel like I was really like a part of hip hop. I was just a guy who liked hip hop enough to do hip hop interviews. I didn't feel like all these music industry people should be talking to me.
Yeah.
I mean, and in that way, that was kind of like a big gift from him. Like aside from just knowing him and everything, is that his success was so massive, and that interview was such a big reference point for him that early in his career that it was like he gave me a crazy gift by letting me do that first interview. That was one of the biggest things that probably ever happened. And then, yeah, I mean, for him to get killed in such a senseless way, it's just.
Is there any update on that case, by the way?
I mean, just bullshit that they're still going.
AL, your mic is not muted.
I don't know if it-
Amsterdam, your mic is not muted.
We can hear you now.
Hello?
Okay, can you hear me now?
Yes.
Okay, cool. Okay. All right. Okay, good, good, good.
But I don't have.
Let me just,
Hello?
because I need to see the chat on another screen, so I'm going to do that. Okay, so basically, as I said in my announcement, I'm not going to be covering a lot of questions, like a lot of questions from the tutorial material, just because there's so many, and I just want to let people that have questions ask their questions. So
Hello?
that's what's going to happen. All right, let me just... Okay. Oh, wow. Okay. I didn't look at
Hello?
the participant number. All right. That's not scary at all.
Hello?
Yes. So can you please make the sound louder?
I think someone has a question.
I think, yeah, just give me a second. Okay, I'm having trouble hearing you guys. Oh, wait. Can someone say something?
Yes?
Okay, I
Hello,
can.
hello.
Oh, Jesus Christ. Okay, all right, okay.
Sorry.
Yes, I can hear you. Okay, very good. All right, excellent.
I've been trying to reach you for a little while now. I just wanted to
Sorry.
say some of us we're not able to get to the tutorial resource files. We don't have it on Moodle.
Oh, you're in
So,
another section?
yeah, I'm in.
Oh, well,
Moodle.
they didn't post this stuff for your other sections.
No, I don't have it at all.
But I told them to. Okay.
You can access it via the email or announcement. There's like a link on there.
Yeah, I clicked on the link, but there's nothing. That's weird.
Okay, because otherwise I can just upload it to a Google Drive and
Yeah,
just
okay, fine.
share it. I can do that. You guys want me? I'll just do that now. Yeah.
Thank you.
Okay. I'm just gonna stop sharing because I think everyone knows why.
I have a question.
Yes.
Yeah, will you be posting the solutions you're gonna be doing right now?
Yeah.
Later?
So there's solutions in the slides.
Oh yeah.
Yeah.
I mean, I thought there was only the problems themselves. Like,
No, there should be solutions. There should be like answers right next to them in red.
oh yeah, no, for some of them. No, you're right. You're right.
Yeah. Okay. Good. Okay. So I'm uploading. All right. Share. Okay. So I'm gonna post this on the chat.
And I see you're recording. So will you post this recording on the Moodle?
Yeah. Yes. Well, so I'm guessing the people in the other section aren't going to be able to see the UJA for my section, so I'll just post it on YouTube. Let me give you a link to my YouTube channel.
Awesome. Thanks.
Yeah, no problem. Okay. Yeah, so I apologize that we're starting late. I didn't. I could have sworn I told the other professors to. Anyways. Okay. So where's the chat? Yeah, just concord your things. Okay, so this should be a link to my YouTube channel, which so when we finish the recording, I'm gonna post it there. All right. Okay, so so I feel like that should solve most. Someone has their hand raised. I don't know if they want to speak. Can ask to unmute you. No. Okay. All right. They lowered their hand. All right. Okay. So let me share my screen again. Okay. So so hopefully most of you can get to that Google link or have the kind of slides uploaded to the Moodle, so you can access that. So whoops. So okay. So essentially, what I'm going to be talking about, I'm going to be doing a couple of questions here. But really, I don't want to go over maybe 3 p.m. for the questions that I want to do, just because I know some of you might have questions. So that's what I'm going to do. So as you can probably tell, there are a lot of exercises in here. So I can only do a few of these. So the first one that I wanted to do actually was a bit of an easy one, which was just exercise 1 here. So in this exercise, what do we have? We have the language L1, which is the language that contains strings of any number of A's, right? So what does this look like? This looks like lambda, A2, and so on. And then we also have L2 as any number of B's, right? So we have lambda, B, B2, and so on. And now the claim here, so it's kind of sucks that you can see the answer already, but the claim here is that L1 concatenate L2 is AN BN for n greater or equal to 0. Okay, so that's what the question is claiming. Okay, and typically I would wait a while and ask for someone to answer. Okay, I see someone answered. Okay, so the main sort of trap here that the question is trying to make you fall into is just because you have the two kind of same ends there doesn't mean that when you do the concatenation here it's going to be the same ends, right? And the reason why is just because what does the concatenation operator do? It concats every string in L1 with every string in L2. So it's not just the string A in L1 and the string A in L2 and concat those together. Or sorry, B in L2. So if you just expand this expression, so whenever students sometimes ask me that they sort of have trouble with these questions, and my trick is just to try to expand a couple of terms for each language. And in this case, apply the concatenation. So in this case, I take my lambda, concatenated with lambda, with B, with B2, and so on. So I'm going to get lambda, B, B2, so on, right? And then you kind of start to see a pattern when you do these concatenations. So now I have A concat with lambda, so that's A concat with B, so that's a B, then AB2, and so on. And so actually what we're observing here is that we're going to take any number of A's, right? Any number of A's greater or equal to 0, and concatenate them with any number of B's greater or equal to 0. So that's why, as Antoine was saying, N and M are greater or equal to 0, and this is actually the concatenation of the language. Okay, so that's one problem, just to get our. I uploaded a different file. Okay, that's not good. But that's just one problem to get us started. So okay, yeah. So I'll just okay. I don't want to kind of. What file did I upload then? Okay, that's weird. Okay, anyways, I don't want to sort of go back and forth and then waste everyone's time. So yeah, I'll upload the slides again after, my bad. But essentially what I was trying to say is that that's the first question that I wanted to look at just to get ourselves warmed up. So I'm not going to go through 2, 3, and 4 unless anyone sort of wants me to. But I was going to look at this one here, this true or false here. That's claiming that L star minus L is equal to L plus, right? So I just want to remind everyone what the definition of L star is. L star is L0 union L1 union L2, and so on, right? So it's the infinite union of the concatenation of the languages with themselves. So it's U from I equals 0 to infinity, Li. And then L plus is L1 union L2 union. So you're doing exactly the same thing as L star, right? But you're just not doing L0, right? So it's Ui equals 1 to infinity of Li. Okay? And essentially here what they're saying is, oh, well, because, okay, so this, okay, so they're saying, well, you're taking L plus, right? You're essentially doing the same thing as L star, except you're removing some things, basically. So the claim here that they're saying is that L star minus L is equal to L plus. Well, that's essentially that's not true, okay? Because of the fact that L plus here, so really they could have written anything here. It could have been L2 or L3 or whatever. The L plus here actually has the L1. So it would be false to claim that L plus is L star minus L. Okay, so that's essentially the idea. And another one that sometimes sort of catches students off guard is if I do L star minus the set containing lambda, then they actually do think that this is equal to L plus. Okay. Let me answer that question in a second. So they say that that's equal to L plus, right? Which is, and the kind of reasoning is, oh, well, L to the 0 is equal to lambda. So if you remove lambda from L star, then you get L plus because L plus doesn't have L1. So that's true unless you have L has something like lambda A, right? Or maybe just L is lambda, actually. So if L is just the set that has lambda, right, then what is L star going to be? So L star is going to be L0 union L1 union L2 union and so on. So L0 is lambda, then union L1 is just lambda to the 1. So that's again lambda. And sort of you continue with a union of lambda because L2 is also lambda square. So that's also lambda. And so you get L star is just the set or the language containing lambda, right? And then L star minus lambda is the empty set, right? Because essentially you're taking the same set here and you're taking the set here and removing it from itself. Basically, you're doing A minus A. So that always gives you the empty set. However, L plus here, so I'm trying to check that this is not equal to L plus. And so the way I can do that is just by using again the definition of L plus. So L plus is L1, union L2, union and so on. So that's going to be lambda, union lambda, and so on. So I'm going to finish with just the lambda here, okay? And I can clearly see that L plus, which is the language containing lambda, is different from L plus minus lambda, which is the empty set, okay? Okay, so hopefully that's clear. So, okay, so we have some interesting questions here. So can we say it is L star intersecting L different from L plus? So L star intersect L.
I mean, doesn't the minus represent intersection?
Yeah, well, so, okay, I see. Well, L star minus L is L star intersect not L.
Oh, okay. My bad.
Yes, so that's super important to remember. That's one of the set properties that's really useful to remember. Okay. So Antoine is saying, okay, so then there's another comment here saying that L star minus L is going to be L0 union L2 union L3 union so on. So that sounds reasonable, right? The only thing is that it's unfortunately not true because of the same reason as before. If L is just lambda, then here lambda, so the set containing lambda is L star, and then L is the set containing lambda, so this would give you the empty set. However, this would not give you the empty set, this would give you set containing lambda. So it's actually, to be honest, it's very difficult to give a closed form solution for this. There isn't one single answer. It can essentially, it depends on the language basically. So that's why you need to be careful here and look at essentially the set containing lambda, the empty set, as well as sigma star. When you wanna see if something is true or not, those are good candidates for counterexamples. Okay. So I think that answers those two comments by Antoine and André. Did you say that if L was L0, it would be true? So I don't know what that means. If L was equal to L0, so you mean if L was lambda? So no, that's I was using this as a counterexample actually. Yes. So I understand. I mean, there are some nice questions here, so that's why I want to address them. So maybe I'll just quickly look at, because someone asked about exercise 2. Okay, so maybe I just want to give a quick comment on this. So I have L is the set of all strings containing W, and LR is the reversal of that. I see. Okay, so okay, yeah. So I see why this is not a okay. This actually isn't a very easy question. The reason why one of the reasons why this isn't true, why the answer is false, okay, is because of the following. So suppose we had the language L as kind of, I want to think of, yeah, okay, so, yeah, okay, so suppose I had W, so I have WWR, W in AB star. So actually, maybe I want to ask everyone this, is this language regular? No, okay, good, okay. Good. Okay, so this language is not regular, and you can prove that with the pumping lemma, but I know that you did that in the lecture. Okay, so we know that this language is not regular, right? However, we could presumably have a language L here that is regular, right? And if L is regular, then the language L reversal would also be regular, right? Okay, so then that means that if I could express this language here as the concatenation of L and LR, if I could express this guy as L concat LR, then that would mean that this guy is regular, which is a contradiction. Okay, so the whole idea here is to make you realize that this guy here is not regular, and in fact, if I could express this guy as the concatenation of two, say, regular languages, then it would mean that it's a non-regular language, which is a contradiction. So the whole idea here is to look at contradictions essentially. Okay. Okay. So, but yeah. So as I was saying, I also agree with, you know, I don't want to spend too much time because I agree that, you know, I don't want to waste everyone's time. But hopefully that's clear for those first two exercises. So I'm actually gonna, if no one has any objections, I'm going to go all the way to the closure property exercises because I know that these get kind of frequently asked in the midterm and in quizzes in general. So I thought I would look at a couple of these sort of hopefully quickly. I was going to do 25 and 27 and 29. So I was going to do these. Actually, yeah, these three. Okay, and then essentially I didn't want to do any more than that because I still want to leave sort of 30 minutes for questions. Okay. So exercise 25 is again a true or false, and it says that if L star is regular, then L is regular. Okay, so again, I'm really bummed out that you can see the answer. It would be nice if someone could say like true or false or whatever. But the idea here and the intuition that I want to give you for this question is the fact that L star is regular doesn't really tell you much about L. Okay, and the reason for that is because L star is such a large language. It's an infinite language, of course, and it encompasses a lot of strings. So it's actually not that hard to see how L star could be regular and how L could not be regular. I want to give you a counterexample here. So a counterexample would be if I have L as AN, BN, such that N is greater or equal to 0, a union A comma B. So I hope that everyone sees that this is not regular, right? So why is this not regular? Well, because I have AN, BN here. Here it doesn't matter that I'm essentially just adding some some finite strings to a non-regular language. Doing that is not going to make my language regular. So L here, that's why L here is non-regular. Okay. However, if I take L and then I apply the star operation, so I do L star, then what I hope everyone could sort of see is that L star is actually going to be A comma B star, okay? And the reason for that is, again, you just have to do the kind of trick of expanding it and seeing what the expression tells you. So what is L star here? Again, it's L star is L0 union L1 union L2 and so on. Okay, so L0 is going to give you the empty string. Then L1, what is L1 going to give you? Well, L1 is going to give you some stuff here, A and BN, right? I don't really care about that. And it's also going to give you A comma B. So it's going to give you all of the strings of length equal to 1, right? And then if you go to L2 here, if you go to L2, then what is L2 going to be? It's going to be L concat L. So that's going to be, you know, lambda AB, A2B2, and so on. And then I'm going to have an infinite number of strings and then AB, right? And then I'm going to do the same thing and I'm going to have AB at the end. So I'm going to take my A and concatenate it with A. That's going to give me A2. And then hopefully you can see that it's also going to give me AB, BA, and B2. So essentially for L2, I'm going to get all of the strings. So all of the strings of length 2. And then what's L3 going to give me? Well, it's going to give me some stuff, right? So I'm ignoring the whole A and BN sort of business there, because all I want to show you is that if I go to L3, I'm going to get all of the strings of length 3, and then L4, all of the strings of length 4. So really L star is going to give me AB star, because that gives me any string over AB of any length, a union something else, right? But this is the universal language, so that's just going to give me AB star, okay? So L star is regular. This is regular. But L is not regular, so that's why this guy is false. Okay. Okay. What is AB? Okay, sorry. Let me just quickly answer some questions here. Okay, so yeah, so Ryan actually got, yeah, excellent. Okay. So AB is just, in this case, I'm just saying AB is the language containing the string A and the string B. Okay, so that's it, right? And yeah, so L star is going to be sigma star. Okay, so now another question here, 27. 27 should be a bit. Yes, so Vatika, again, I'm sorry if I always butcher people's names, but I'm sorry about that. AB, yeah, we're adding, so we're taking some non-regular language, and then we're unioning it with the language A and B. Okay, so we're adding the two strings, the two symbols actually, AB, and then we see that if we take out star, then that's similar to doing AB star union something else, but AB star is the universal set. And so that encompasses everything. So we get AB star. Okay, so I don't know if that answered the question, but let me just go to 27. So what does 27 say? It says that if L1 intersect L2 and L1 minus L2 are both regular, then L1 and L2 are both regular. So, well, it does say it's false, but maybe if someone could try to think of a counterexample while I sort of try to explain it. So what is this saying? This is saying that if I know that the intersection of two languages is regular, meaning that there exists an FA that can accept it, for instance, and that L1 minus L2 is regular, right? Then this should somehow mean that both are regular. Okay, so the reason why this is false is, yes, very good. The reason why this is false is because we're claiming that both need to be regular. Okay, so that actually doesn't need to be the case. As someone did point out, if L1 is the empty set, then if L1 is the empty set, you can essentially do anything with L2, right? You can make L2 be the set of palindromes, the AN BN square, right? It doesn't matter, right? Because L1 intersect L2, the empty set intersect anything is always the empty set, right? And the empty set minus L2, so if you have the set that has nothing and you remove something from it, you're also going to get the set that has nothing. So both of these are regular. But now if I pick L2 as some non-regular language, so let's say ANBN, then that's a counterexample for exercise 27. Well, okay, so good question. So that's a good question. Do either, so does L1 or L2 have to be regular? So that's something that that's a good question that I'm not sure right now. Off the top of my head, I would say that yes, there has to be one that's regular. But I might be mistaken. Yeah, so I'm not sure. I'll add that to the exercises when I post them again. I'll make sure to add that. Unless someone's actually answering the question right now. Okay, I'm sorry. There's a lot of comments here, so to be honest, I'm a bit. Yes, excellent. Yeah, so I think Nicolo's example works because yes, actually yes, that's very good. Yeah, because the intersection is empty, and wait, why is L1 minus L2? Okay, so someone is saying L1 is AI bj, I greater than j, greater or equal to 0, and L2 is AI bj. Okay, I see what you're saying. Okay, so yeah, let me just write out a couple of the strings here. So for instance, if j equals to 0, then we have, what do we have? We can have essentially A2, A3, and so on. If j is equal to 1, then we can have A2b, A3b, A4b, and so on. If j is equal to 2, then we can have A3b2, A4b2, and so on. Okay, so then what does this guy look like? If there's an intersection that looks non-regular, then this might not work. So it's the same, right? Yeah, it's exactly the same except that these are B's. Yeah. Okay, so I actually don't think that's right. And the reason why I don't think that's right is because yes, L1 intersect L2 is the empty set. Clearly, there's nothing that is common between the two. But okay, but if L1 intersect L2 is the empty set, then if you're doing L1 and you're removing L2 from it, then essentially you're going to get back you're going to get back L1 because when you're taking L2 and you're removing all of the stuff in L1 from L2, but L1 doesn't have any of that stuff. So yeah, exactly. So once you're at L1, if you're removing stuff from it that it doesn't have, then you're just going to get back L1, and L1 is non-regular. Okay, so yeah. So I hope actually that was actually a really nice question. I hope some people got that. That was actually a very nice point. Because it does seem to me that one of these two languages actually has to be regular. Otherwise, it would be very difficult to say that these two things are true, right? Okay, so someone just gave a full-on proof, which is nice. L1. Yeah, so someone is saying, okay, so two infinite languages cannot have a finite intersection, so that's definitely false. I just want to make that clear to everyone. If L is LA star and L1, L2 is LB star, then these are both infinite, but their intersection is the empty set, which is finite. So they do have a finite intersection, so that is possible. So as for Kevin's solution, L1 okay, I'm not quite sure. Yeah, Kevin, I'm not entirely sure what you're saying there. I feel like you're giving a proof to show that one of them has to be regular, but I'm not. Yeah, let me come back to that. Let me just do 29, and because 29 is I can actually answer, and then I'll come back to your comment. Okay, so but just if I don't answer, make sure to let me know. Okay. So 29 is saying that the infinite union of finite languages is regular. So again, I encourage someone to send out a counterexample before I actually give one. A finite language, just to remind everyone, finite language just means you have a finitely countable number of strings. So what the hint here is I should be looking at an infinite language that is non-regular, because of course there are no languages that are finite and non-regular. So one classic one that I know everyone here likes is A and Bn. So I know that this is non-regular. Is there a way to make this be the a union, the infinite union? So what's an infinite union? It means you start at 0 and you go to infinity, and you're unioning finite languages. So every time you're doing the union operation, you have a language which has a finite number of strings here. Okay, so what does that kind of look like? What would be a possibility for something here? Doesn't look like anyone. Okay, so one idea that you could use would be if you infinitely union AI BI, right? So if you do AI BI, then this clearly gives you AN BN, right? These guys are all finite, right? So what I'm doing really, what is this saying? It's just saying take lambda as one finite language, then union it with AB, and then union it with A2, B2, and then so on. And each of these components are like finite pieces. But now, even though finite languages are regular, if you take the union of all of them, it might not mean that their union is regular, and this is a counterexample. Okay. Okay, so those were the only questions that I wanted to look at, because as people were pointing out, there are way too many. So I don't know if anyone. Yeah.
So I didn't understand for number 30 how that was false. Can you go over that again?
Yeah, so sorry, if you could, because I couldn't hear the exercise number.
Oh, sorry, number 30.
30, yes. Okay, that was, so I did 29, not 30. 30 is different. But I could do.
No, the previous one where you showed us the intersection is equal to the empty set.
Oh, you mean?
Yeah, where L1 is L1 is
Oh,
L of A star. I didn't understand that. Yeah.
Oh, here.
Yeah.
Yes. Okay. Oh, okay. Well, okay. Nice question. So, well, what is L1? L1 is L A star. So what does that mean? It's any number of A's, right? So it's lambda, A2, A3, and so on, right? So this is a infinite regular language, right? Of course, yes. I hope everyone knows that. And then L2 is the same just for B's. So this is also an infinite regular language. Okay, so I see why you said that. Okay, I don't know if it's because I made a mistake, because I did. But so what I should have said was that L1 intersect L2 is the set that contains lambda, because the only element that is in common between L1 and L2 is the empty string. So L1 intersect L2 is the empty string, because that's the only element in common. But the main point that I wanted to make here was if you have two infinite languages and you're doing their intersection, then the intersection can be finite or infinite. So it's not always one or the other, okay?
Right, but the question says if it's regular.
Oh, is it? Well, this, so, okay, so that's a different question. If L1 is regular and L2 is regular, then by the closure properties, L1 intersect L2 is always going to be regular.
Yeah, so that's why I was confused, because this is regular, and
Yeah.
but the question 30 says it's false.
Yes. Okay, well, okay, so that's question 30. Okay, you're kind of mixing me up with the questions here, but exercise 30 is saying the infinite intersection of regular languages is regular. So this is not an infinite intersection. This intersection is finite because there's a finite number of languages being intersected. This question is actually much harder than what I was showing. And I suppose I could do exercise 30 because someone asked. So it says that the infinite intersection of regular languages is regular. And very shockingly, I'm sure some people think that this is surprising. This is false, okay? And the reason for that is not super obvious, okay? So this is actually going to maybe confuse some of you. So I'm going to do my best not to sort of do that. So if I have AB star, okay, so AB star I know for sure is regular. And now let's say I'm going to remove from it a lambda, right? So this is still regular, right? Because you're taking a regular language and you're differencing it with another regular language, okay? So let's say this is L0. Then L1 is, let's say L1 is AB star minus, let's say, AB. Okay, no, sorry, not A comma B, AB. So I hope someone sees where I'm going with this. Then L2 is A comma B star minus, what is this? A2, B2. Okay, and sort of in general, Ln is going to be A comma B star minus AN Bn. So now what happens? What happens if I do L0 intersect L1, intersect L2, intersect L3, and so on? So hopefully what some people are going to see is that this intersection, what you're doing is you're taking this guy and then removing from it lambda, AB, A2B2, A3B3, A4B4, and so on, right? So what is that going to be? Well, that's just going to be sigma star minus ANBN for n greater or equal to 0, right? So is this, okay, now I want someone to answer, is this guy regular? No. Okay, very good. Very good. It's not regular. Why? Because say this is L, right? This whole expression is L complement. So if this whole expression was regular, then if you took the complement of that expression, so if you took the complement of the complement, then you would get L as being a regular language, which would be a contradiction, okay? So, so that was the whole sort of idea behind exercise 30. I admit that this one is actually one of the harder ones, and that's not super obvious to see. But the intuition that I just want to say here is that the fact that it's an infinite intersection means that you can't control what's going on. The fact that you can't control what's going on. And so I don't want to say anything wrong here. Now I feel that there's some pressure. So you can't
Uh,
control what's going on
but-
essentially.
Yeah, I don't understand though why what you got. It's not regular, the final language.
Why is this not regular?
Yeah,
Okay, so do you agree? So do you agree that this is equal to an bn complement?
yeah,
Okay, good. So if this is regular, right, then we also know that the complement of a regular language is regular, right? So if I take this language that I think is regular and I apply the complement, then complement is like minus minus. You get yourself, right? So what is that going to be? It's going to be an bn for n greater or equal to 0. So then the conclusion that I get is that this is regular, which now I hope you agree is a contradiction because we.
yeah, I get it.
Okay. Okay. Good.
Yeah, that
Very
makes
good.
sense. Thank you.
No problem. If it was the intersection of infinite finite languages. Okay, infinite finite languages. I don't think those are things because
They mean the infinite intersection of finite languages.
the infinite intersection of finite languages. Okay, nice question. Well, nice question. So if you have the intersection, so let's say you have L1 intersect L2, intersect L3, and so on. Each of these are finite, right? So if you're taking a finite language and you're intersecting it with another finite language, can this be, so my question to you is, can this be infinite? Can the elements in that set that you're intersecting be infinite? Can you have an infinite number of elements? No. Okay, good. Why? Because let's say you have L1 has a 5. Yes. So that's one way of thinking about it. If L1 has 5 elements, maybe L2 has 10 elements, but there's no way that you have a set that has an infinite number of elements. So you can never sort of go to that point of infinity, right? The largest is when Li are the same set. Yes, I think I agree with that. And so what I'm trying to say essentially is that this infinite intersection, because it's a finite languages, is going to be finite. And we know that all finite languages are regular. So this would be a regular, yes. So nice question.
Can I repeat the question, please?
Can I repeat? Yeah, of course. So
Oh my God.
the the question was, you have an infinite intersection. So let me write it like this. I have an infinite intersection of finite languages, right? So what is the intersection doing? It's taking all of the common elements from all of the common elements of all of the finite sets, but there are only a finite number of those. There's only a finite number of common elements. So if you have a finite number of common elements, right, then you have a set which has a finite number of elements. So you have a finite set which is regular. Okay. So I don't know if that makes it clear. Not quite.
May I ask a question, please?
Yes.
Yes, could you go to the number 29?
Number 29, yes.
Yeah. So you said that you said that the infinite union of finite languages is not regular, but isn't regular languages closed under unions?
Aha, yes, good. It's closed under finite union. It's not
Oh,
closed under infinite union.
okay.
And by the way, I didn't say that the infinite union of finite languages is non-regular. I said sometimes it's non-regular and sometimes it's regular.
But
So
we
if
assume that's always regular.
No, you can't. Don't assume anything. It could be regular if, say, you were unioning the empty set an infinite number of times. If you do the if you do the empty set union the empty set an infinite number of times, then that just gives you the empty set, which is regular. So sometimes it can be a regular language, other times it can be non-regular. But what's very important to remember in general when you're looking at true-false statements is that this statement is saying that this is true for every language, right?
Mm-hmm.
And that's not possible. It can't be possible for every language. Okay, so that's why it's false.
So we can apply the same principle to the infinite intersection of regular languages is regular.
Yes.
Okay.
Yes. So sometimes it can be regular, other times it can be non-regular.
Thank you very much.
Yeah, no problem. Good question. Yes. So yes, our special guest is helping me out. Thank you. So I don't know. Hopefully that this question, when it was an infinite intersection of finite languages, hopefully that's clear. Essentially, it's because as someone was saying, you essentially have a maximum number of elements which you can have in that infinite intersection. Because you have a finite number, you can upper bound the number of elements in that set. Okay, so so now there's another nice question, which is, what's the difference between L star and sigma star? So it's very good that you're asking this now rather than tomorrow. Sigma star is like the universal set. Okay, so sigma star is the set or the language that contains all of the possible strings over your alphabet sigma. So if sigma is AB, so let me say not equal in general. So if sigma is AB, then sigma star is all of the strings over AB. That's it, right? So any string of length 0 over AB is in sigma star. Any string of length 1 over AB is in sigma star, and so on for infinity, right? Sigma star is an infinite language. L star is also an infinite language, but L star is defined by both of these are defined by the concatenation, by the, star closure operation, but L star in particular is L0, union L1, union L2, union L3, and so on, right? So this is the definition of L star. It's the infinite union of the concatenation, if you will. If you kind of look at concatenation in a very loose way, it's the infinite union of the nth concatenation of L, essentially. So this is not in general equal to a sigma star, because, for instance, let's say you have AB. Well, what is AB star? AB star is going to be AB0, so that's lambda, union AB1, that's that's A1, union A2, that's A2, and so on, right? So you can see that this is clearly different from AB star, which contains all of the kind of permutations of any length with B's, as well as only having B's, right? So clearly this is actually, I was going to say smaller, but this is not equal to sigma star. Okay. But good question. Can you give? Yes.
Could we just say that L star is a subset of sigma star?
Yes. Yeah. I mean, anything is a subset of sigma star. If you have a language L, which is defined over sigma, then the definition actually one of the definitions that you can give for L is that L is a subset
Is-
of sigma
right.
star. So yes,
Has to be. Yeah.
yes, of course. Very good.
Cool. Thank you.
No
Would
problem.
that include the empty sets?
Yes, yes,
The empty set is also a subset of sigma star?
yes. The empty set is a subset of every set.
Okay,
Um,
excellent.
Yes, very good.
Just to be sure, so L star is linked to the language and sigma star is linked exclusively to the given alphabet. That's the main difference between the two.
Yes, yes. L star, you're applying the star closure to the language. Sigma star, you're applying it to the alphabet. And by applying it to the alphabet, you're giving yourself all of the possible combinations for that alphabet.
Perfect, thank you.
Okay, no problem. Okay, so okay, I did give an. Can you give an example of sigma? I'm guessing you meant sigma star. Yes, okay, yeah. So that's one example. Oh, a sigma star. Well, okay. Well, sigma star is just if you take a b star, then that's it. It's just any permutation, as I said, of any length of the alphabet. Any string of any length over the alphabet AB. Okay, so that's what this means.
So
Okay.
it's all possible permutation with AB.
Yes, of any length. Yes.
So it's finite. It's infinite. I'm sorry.
Yes, infinite. Yes.
Okay.
In general, no. I was gonna say, but yeah. Okay. I was gonna say L star. So maybe I'll just ask this for everyone. Is L star always infinite? No. Okay. Someone says no. Good. Okay. Good. Lots of
No,
no's.
yeah.
Yes. Yes. Excellent. So someone said lambda.
There you go.
So yes. Good. Also the yes. That's why the set containing lambda and the empty set are the best languages after sigma star. Okay, so then there was a question on Discord. That's dangerous. Okay, so
I opened it. It's legit.
okay, it's legit. All right. Okay, so I do see it. Yeah. Okay. Good. It's a good question. Where's the chat? Okay. So okay, I'm sorry, I'm going all over the place. So let me go here. So one of the questions here was L1. Okay, L1 L2 reverse. So what is this equal to? And there's two options. There's four options, but really there's two options. There's L1 reverse, L2 reverse, and then there's L2 reverse, L1 reverse. Okay. So the hint, I want to give everyone a hint before I answer it is, if you look at actually the analogous result for strings, so let's say you have a VW reverse, then what is this going to be equal to? So is it going to be equal to V reverse W reverse or W reverse V reverse? Well, a simple way of not proving but checking is using an example. So let's say I say ABA and what's another one? Let's say W is BA. And I have to make sure they're not palindromes. Okay, they are palindromes. Okay. I love palindromes, but not for this kind of question. Okay, so VW is what? It's ABA, AB, right? So if you take the reverse of that, then what you're going to get is BA, ABA, right? So what is BA? Well, that's W reverse. And what is ABA? Okay, well, everyone can see that this, if I had chosen something that wasn't a palindrome, yeah, I didn't realize that until just now. Then damn it. If I put a
Would it be
B,
easy to
The
have
example
an-
still works.
Yeah, I know. No, I know. It's just, it kind of sucks because I'm for sure someone got confused by that. But so I changed it to BBA. So then you get BA and BB. So that's VR. Okay. So okay. So the answer here then is it's WRVR. And so really, this question is just actually an extension. Is an extension of this property, but if you're applying it to strings. Okay, so in fact, that being said, then you can actually show, and sometimes this is done in assignments, but unfortunately it wasn't done in this one, in this session, that you can have, well, that L1, L2 reverse is L2 reverse, L1 reverse. Okay, so Antoine wasn't 100% sure, but your hunch was good. Okay, so so it is sort of past 3:30. I am having fun though, but
Please
yes.
don't forget to give us the right file.
Yes. Upload the right file. That is, yes, for sure. I think there was a question though that I didn't answer. No, there was, I think, Kevin's question. Which, to be honest, I was a bit unclear what was going on there. I don't know if Kevin is here and if he wants to talk about it, but yeah, I'm not, I wasn't entirely sure what was going on. I don't know if you were proving L1 minus L2. Yeah, so I wasn't sure. But I mean, I'll post my email in the chat. So if you have any more questions, specifically Kevin, because I didn't answer your question, then just shoot me an email. That doesn't mean that, yes?
For other sections, is it possible for me from a different section to attend your tutorials?
Yeah, sure, you can do that. Yeah, just shoot me an email and I can send you the link.
Thank you very much.
But please 110 people, please don't email me all at once. Okay, that would be bad. Okay.
Okay, I'm gonna wait a week.
All right, thanks. Okay. Okay, but yeah, so if there are any, I don't know if there are any other questions. I'm sure there are a lot of questions actually, but questions that I can address. I don't mind staying around for a bit more.
Hi, sorry.
Yes.
I didn't know that there was a session, so I came in late. So I don't know where to get like the examples that you just shown.
Yes. So I'm gonna. Okay. So someone posted a. Someone posted a link. I'm also going to. Yeah. It sucks that I can't talk to the people from the other section.
Oh, I see. Well, I'm with Dr. Dennis, so I can't have access to the link directly. That's why.
Okay. Yeah. So because I was gonna post something on the drive. So on. So let me again post my. Okay, just give me 2 quick seconds. Actually, what I'll do is copy link. Okay, so I'm gonna so there's a drive for the tutorial folders, and then I'm gonna upload. So this is I think this should work, right? Yes. Okay. So this is the drive for the tutorial folders. It's the ones that are on the Moodle page for Dr. Shiri's section. I'm going to upload the correct version of the midterm review slides there. Yeah, and I'll also, I guess I'll post my email in, I think my email is in tutorial 1. Is it? No, it's not. Okay. I'll post an extra file with my email. Yes, I'll do that. Okay. Yes, I'm gonna post the recording on YouTube. There's a lot of things to do. Okay, so let me just. But I don't know if anyone has actual questions about the material. I can still answer them.
I actually have one last question if you got time.
Yes. Just let me recording on YouTube. Yes. Go ahead.
I was just wondering if we could go through some examples, maybe that you have where we like do a generalized transition graph, some sort of like conversion from a
yes.
DFA to a regular expression.
Yes, I think I have one of those. Yes, I do. Okay, good.
Nice.
Yes, sure, I can do that. I can do one of those. Okay, so right. Okay, so I'll do this one. So I just want to remind everyone that's still here, what's the idea of you have this FA and you want to convert it to a regular expression, is you just want to essentially remove all of the intermediate states, and you want to get to an FA that looks, or actually a GTG that looks something like this, okay? Because once you have an expression that looks like this, if this is R1, this is R2, this is R3, this is R4, then it becomes easy to write the regular expression. There's a simple formula for that, and I'll just remind you it's R1 star, R2, and then R4 plus R3, R1 star, R2 star. Okay, so that's the general formula if you have this. So the whole idea behind transitions is you want to eliminate intermediate states, and to do that, you want to eliminate intermediate states to get a GTG that looks like that. Okay, so if we have this example here, we have this FA and we want to convert it to a regular expression. The first intermediate state that I'm gonna, and the only actually one that I'm gonna want to remove is this guy, right? Because that's the one that essentially is kind of the longer way of going directly to 2. Okay, so I have here a 0, and I have here 2. Okay, so this question isn't that okay, because it doesn't give you that many sort of options really to sort of demonstrate what's going on. But to eliminate this guy, essentially, you need to consider all of the roots that go through 1. Okay, and the only root in this case that goes through 1 is to go from 0 to 2, right? To go from 0 to 2. Then what I can do is I can go through 1 by either A or B, stay in 1 a bunch of times, and then go to 2 with lambda. Okay, so to go from 0 to 2, that means that to go from 0 to 2, there is an option that doesn't exist, that didn't exist before eliminating that intermediate state from 0 to 2, and that's going to be A or B, a B star, a lambda, but lambda, as you know, is just, so if you take something and you can cat with lambda, that's just the thing itself, the string itself. And then I can keep my my transitions for 0, and then the one to go back from 2 to 0, that's B, and then to stay in 2, that's A. Okay, so just to be clear, just to make sure that everyone's on board, I removed this guy, and to preserve all the transitions, I needed to consider all of the transitions that went through 1. In this case, there was only the one 0 to 2, right? To go from 0 to 2, you can take 1. But if, for instance, there had been something like this, then you also needed to consider the additional transition that if you go from 0 to 1, so if there was this, if you go from 0 to 1 and then back to 0, you can do that using 1. So then you would add a transition here. Okay.
That transition, sorry, that plus.
Yes.
Would that have been like from 1 going back to 0 back to 1, or?
So let's say this was
like,
A.
Yeah.
Right. So you can, if you're in 0, how can you go back to 0? You can either use this A, so this A, or,
Yeah.
oh gosh, or, so that's the plus, you can go to 1 with A or B. So go to 1 with A or B,
Mhm.
stick in 1 for a couple of times with B, and then
Right.
go back to 0 with A.
I see.
Okay?
Yeah.
Okay, good. So there seems to be, did I make a mistake? Yeah, I don't see a mistake. But okay, okay, cool. Okay. And then so once you're here, then essentially you just apply this formula, right? So then this is the one with A. Yeah.
I have a quick question for transition from 0 to 2.
Yes.
Is it B star into A plus B or B star plus A plus B? I'm quite confused.
Well, to go from 0 to 2, you either read an A or a B. So you read an A or a B, right? You're going from left to right. You have to read, always read these guys from left to right, okay? So you either read an A or a B, and then you stick in 1 for a couple times with B star, and then you use the lambda to go to 2. Okay?
It's not a plus B star, right? It's because it could be either way. You take a B star, you could take just B. Wait,
this is a star, yes. I don't know if that's what you're asking.
okay.
C'est bon? It's good?
Yeah.
You don't sound convinced.
I think you should zoom out just to compare from.
Yeah, maybe. It's a good idea.
Yeah.
Well, this was the one. This was the one where I added the A here, so it's not going to be the same. But
Oh yeah. No, I
yeah.
understand. Makes sense.
Okay, good. Okay, good. Okay, and then yeah. So maybe I'll just essentially then you would just apply this formula, right? So R1 is this, R2 is this, R3 is this, and R4 is this, and then you would get your regular expression. Okay. Okay, so I hope that's clear. Okay, it's not clear. There's a lot of questions about this. How you got R1 again? Okay, R1. Okay, just to make sure that everyone's clear on this. This one was because I was using. I added this extra edge here. I added the edge from 1 to 0 with A. Okay, and so if you're in 0. If you're in 0 and you want to go back to 0, you have two options. Either you can read an A, so you can read an A here, or you can read an A or a B. You can read an A or a B, then read a bunch of B's, and then with this A, go back to 0. So with this A, go back to 0.
Shouldn't the A be a star, the first A?
So yes, but it doesn't matter. So the reason why it doesn't matter is because when you do your final regular expression, this is going to be all of that star. Okay, so yes, you can write A star, but that's just kind of redundant, basically.
It's basically already part of the loop. So
Yes,
you're already starting.
Yes, exactly.
We have a path from 0 to 1 and we have path 0 to 0.
We have a path from 0 to 1.
And to find the regular expression, to simplify the
it's fine.
Is it so the I'm trying to understand the self loop on 0, basically how you came up with that one. So basically you went to 1, 2, and then that's what you did, right?
Sorry, so for this one or for this one? So for 1 or 2?
No, for 2.
Okay, yes, so to do 2, let me clean this up a bit. To do 2, there's 2 ways of, if you're in 0, right? So what is this saying? This is saying, if you're in 0, how can you go back to 0? Well, here, if you're in 0, there's 2 ways of going back to 0. You can either read an A, or you can go from 0 to 1, then stay in 1, and then go from 1 to 0. And that's essentially what this is doing.
Oh, okay, perfect. Thanks.
Okay, no problem. All right, okay. I hope I hope that's clear. Someone asked where you can get that formula. That they're in the lecture slides as well. They're in the tutorial slides, lecture slides. They're in a lot of slides. They're also in the book. So if you can't find them, they're in the book on the regular expression section, converting FAs to regular expressions. Did I miss any question? Yes.
Actually, just one question about the file that you're working with.
Yes.
So is this a tutorial file or like this sheet of exercises? Where is this?
You mean what am I writing on?
Yeah.
This is a OneNote file.
Oh no, I'm talking about the like the file itself.
The slides or
yeah, the slides. Sorry, slides.
Tutorial, like midterm review tutorial. Like, I'm sorry, I don't quite know what you're.
Okay, I was just wondering where I could get this midterm review.
Oh yes. So I don't know if you're in Dr. Shiri's section.
I am, yeah.
Okay, so they're under tutorial resources for week 7.
Okay, cool.
And for the people not in Dr. Shiri's section, I'm going
Nice.
to post it would be nice if you could pin a message in Zoom, but I'm going to post it on the drive that I have. Okay, so
thank you.
No problem. Okay, so I didn't do an example on pumping lemma. The questions here on pumping lemma are, there isn't one like actual like prove using the pumping lemma. They're more like, these were more to make you understand that you need to correctly know what the pumping lemma says and how do you correctly pick your W, or how to identify which W's are right and which aren't. So that's very, very similar to the quiz. Okay. So for these questions might take a lot of time to explain. So if they aren't clear, just send me an email. And if you're in Dr. Shiri's section, then I did 2 tutorial videos on the pumping lemma. Okay, so and one of the tutorial 6, I did a question almost exactly like this, right? So yes. Okay, then someone said question 6. All right. Okay, I mean, I do need to go at some point, but oh gosh. No, there isn't a. If you're in Dr. Shiri's section, there isn't a link. There is a link. It's on the Moodle. If you're not, then there isn't, unfortunately. I mean, I could upload them to YouTube, but you know, the midterm is tomorrow at 10 a.m. I think if anyone's still kind of reviewing the material for the midterm, I think you should go review the midterm for the midterm sort of yourself rather than listen to me, because I know it might seem super useful listening to me, like, oh yes, I see what he's saying, but try to actually sit down and sort of read your notes, like look at these questions. And I would really recommend the people that stick around for a while longer just to do it if you're already like almost ready, or you just want to like touch up on some things, okay? Because I don't want to be like a supplement to studying, okay? A replacement, sorry, to studying. Yes, so there's a link that I posted in the Zoom chat a while ago to the folder that's going to have the tutorial slides. Okay, all right. Okay, I'm going to do question 6 as the last question, and then I don't think I can take more questions after that. Yes, thank you. Is that the right link? Yes, thank you, Stephen. Thank you for helping me out. No, don't be nervous. And don't be nervous about the exam. Just if you study, really honestly, if you study and you understand material, it's gonna be okay. Okay. But I am going to do question 6, and I think that's the because this one actually takes a while to do. Okay, so what are the strings of length 3 or less in L2 minus L complement L? Okay, so L2, I'm just going to write it out, L2 minus L complement L. So what is L2? It's A, B, B, A, A, B, A, and then it's A, B, B, A, A, B, A. And then I want to take the intersection of L. So here I'm, sorry, the complement of L. Here I'm assuming sigma is AB. So what is L complement? Well, in this case, it's everything not in L, which is in sigma star. So lambda, AA, ABA, BB. And you're going to see that's actually going to be enough. And then L is, again, A, B, BA, ABA. Okay. And the trick that I want to give everyone for these questions is, if you want to look for strings of length 3 or less, is don't try to do more work than necessary. Here, I'm writing ... because I only care about the strings of length 3 or less. Okay. So I don't care about the strings already that are length 4 or more. Right. So that's why try to keep the work as compact as possible so you don't get mixed up. Okay, so then the next step in this is I'm just going to apply the operation. So I'm going to take A and concatenate it with each of these. So that's going to be AA, AB, ABA, and there is ABA. I'm just going to ignore it because it has length 4 or more, and I'm only interested in length 3 or less. So I'm just going to ignore it because it's going to give me extra work for no reason. Then B, I'm going to concatenate it with A, so BA, with B, so BB, and with BA, so BBA. And then again, I'm going to ignore this one because it gives me length 4. Then BA is going to be with ABAA, and BAB, and then BA with BA is going to give me length of 4, and this is going to give me length of 5, so I can ignore that too. And then ABA with any of these is going to give me length of 4 or more. So I can just write ... and actually I just care about these guys, okay? And then I'm going to do the same thing and do minus. Yes, so minus, and again, notice here, I didn't write out the strings of length 3 or more because I know I'm going to concatenate them with strings of length at least 1. So I'm going to get strings of at least 4, which I don't care about for this question, okay? So now lambda concatenate with each of these guys. That's going to be A, B, BA, ABA. And then AA with each of these guys is going to be A cube, AAB. And then I'm going to ignore the BA, ABA because it has length 4 or more. Okay. And then what else? There's going to be BA with A. So that's going to be ABA. And sorry, AB with A and AB with B, so ABB, and then BB with A, so BBA, and BB with B, so BBB, right? And the rest are going to give me strings of length 4 or more, so I don't care. Now the last step is just to see which are common. So is AA in this guy? No, it's not, so I can put it here. Is AB in this guy? No, it's not, so I can put it here. Is ABA in this guy? Yes, so I can cross this off. Is BA in this guy? Yes, so I can cross this off. Is BB in this guy? No, so I can add it. Is BBA in this guy? Yes, so I can cross it. Is BAA in this guy? No, so I can add it. And is BAB in this guy? No. So then that would be my answer. Okay. And that's the trick for these kinds of questions, is don't do more work than necessary. Okay. Okay. So then there's a bunch of questions of what type of questions and midterm, you know, obviously can't answer that. Yes, okay. Yes, so yeah, but there is an announcement on the format of the midterm. If you haven't seen that yet, there are a few announcements that I hope each of your professors, well, I know Dr. Shiri announced it. So yeah. So, okay, so again, just for everyone's, I'm gonna repost the Google Drive link one last time. One last time. Okay, so please, I know some people want to say thank you, but just like, please try not to make the link go too far up. I know that's kind of a jerky thing to say, but it's just for everyone's benefit. And then let me post my YouTube channel's link. So I'm gonna, okay, all right. Unless there are questions. If there are questions, I can definitely take maybe a few more questions, but otherwise I think that's gonna be it.
Thank you.
Yeah, no problem. All right, so good luck, everyone. I'll make sure to post these right away. And yeah, I'll see you when I see you.